Hello everyone, my name is Saksham Dikshit and this is my channel Pentest Diary. So today I'm starting a new series and which I call it as a Docker container security, and this series is simultaneously be going along with the lazy programming series itself. So it's not yet like lazy programming series is not yet completed. It's almost a 28th lecture which you are seeing it tomorrow, and then after that itself simultaneously I'll try to make both the series itself. So this is also one of the series which I'm starting it, which I have talked about earlier also. So I'm starting this series itself, and alternately you're getting the email, one of the feed from the lazy programming series and one from the Docker security itself. So I'll try both the combinations. Like Docker security is one of the things which I wanted, like from so long you're not getting any security related stuffs after Raspberry Pi itself, so you're continuously getting a programming stuff related. So that was the reason I'm starting a new series, and that we call as a container and Docker security itself. In this itself, a theory portion is a majority of the stuff itself. Like in the few initial lectures, I'll try to cover the theory part. This is a beginner level to the reach to the intermediate level itself, so it's not a advanced level security series, but the thing is I'll try my best to get it cover the stuff so that you are able to understand what is Docker. And this is a boom topic right now. Everyone is looking for the Docker security, like in the industry itself. When you're talking about, like, if you are just a fresher or you're just having experience of 1 or 2 years itself, most of the industry, most of the organizations are looking for the Docker security. So to perform the Docker security itself, either couple of automated tools are also available in the market itself, but that's a solution is just to a limited zone itself. Like if your organization don't have that like tool itself, then in that case you feel like you don't have anything in your hand itself. To overcome that problem itself, I'll try to make those things to be feasible for you, so that even if the tools are not available, you can able to do that assessments from your side and how to harden it. Everything I'll try to get it covered in this video, in this complete series itself. So we'll start with the theory part, which we call it as a container image and the container. So what exactly the container and the container's image? So I'll give it a one-liner statement about it so that everything will be clear to you. What is a container image and what is a containers? Okay. So after that, I'm reading the content, whatever the content you are seeing on my screen itself. I think it's almost a 2 pages content. Even I have prepared that block diagram also. So everything I'll try to get it covered in this video itself, but I'll just want to make you understand in a one line itself what is a container. When anyone asks you about it, what is a container? So whenever we are running a container image, and after running that image, whatever the instance you're able to see on your screen, like once you run that image, you're able to see one instance. Like definitely when you're running that image, then after that there is an instance will be created, and that instance we call it as a container. So whenever anyone asks you about it, what is a container? Container is always be an instance. When we are running the container image, whatever the instance get generated, that we call it as a container. Okay, now you definitely ask me, like, if that is a container, so what is it the container image? So container image is considered it's holding a lot of things about it. Like it's having the application, it's having the scripts, it's having a lot of things over there. It's a runtime, system tools, libraries, settings, a lot of things coming under that category for it, that combinedly we can call it as a container image. So container image, it's a type of thing which having a lot of things related to your application, related to that repository, dependence, everything inside of that itself. But when we are running that image, and the instance will be generated, and that instance we call it as a container. So now I'll just read the content and try to make you understand about it. It's a similar type of thing. So this is the crunch of it, which I have given as a summary section of it in the initial phase itself. So now I'm reading the content for you and explaining about each and every line. So imagine you are a developer and you need to deploy an application. Traditionally, this could be complex process involving setting up the right environment, dependency on every machine. Containers offer some more efficient solution by other container images and containers itself. So like practically, if I talk about like earlier, what is happening, like when you try to get a deployed any application, so you require a server, then you have to deploy that, and you have to make it a replica of it, taking a backup of it. Lot of things to be required over there itself, which combinedly will solve the problem of making that application feasible, available for everyone itself. But nowadays, what exactly is happening, we build that application and we deploy it on a Dockers. By that way itself, we can make it a clone of it, and in fraction of seconds we can run any image at any point of time itself. Like even if anything is get crashed, anything happened to our image, but our image is there with us itself, and we can run it we can restart it and it will run for us faster. So instead of we're talking about that it's having a less space to be get it consumed, that was the reason behind it. We are utilizing a Docker now. So now talking about what is a container image and why we are calling it as a blueprint itself. So a container image is a self-contained file that holds everything need to run an application, code, runtime, system tools, libraries, and the settings. These are the things I told you about it. Like at the time when we are building a container image, these are the things that are coming under that. Like it's a similar type of operating system. It's not running that, but everything on a hard disk itself, we can call it as a container image. So when everything is present over there itself, like your files, your operating system details, everything is present over there itself till you're not running it. So once you run it, it becomes as a container itself, as it's running as an instance, and that instance we call it as a container. Now we go ahead for the next section for it. Think of it as a template or a blueprint for creating a specific environment. So it's a type of specific environment. Take example as a blueprint in the context, like if we want to make a specific environment, we can do in such a way. So like any different type of customization we're supposed to do it, we can do in such a way. So making the images as per our need, we can customize that and then we can utilize it. Now if we're talking about the next section for it, images are typically lightweight and portable, allow them to share and deploy easily across different systems. So it's that was I can say that is the beauty of a container or Docker itself. Like you can it's a portable images, you can give it, you can send it to a person itself, whomsoever you want to get it, share that, and that person can get it deployed and run that on your system itself. Just have that software on a system and you can run that. So there is nothing like that extra stuff you required. Nothing like you required multiple core systems, you require a lot of RAM, a lot of things is not at all be required over there itself. If you have the Docker over there itself, you can run that very easily. It's a portable, it's a lightweight portable images which you can share with anyone itself. So if you want to any other type of assessment also, it's a bit easy. Like instead of we're talking about like if we have to harden or perform the testing on any images of a server itself, at that time itself either we have to run the VMs or such type of tools. But in case of container images, it's a bit easy for us. They simply have to provide the images. We simply have to run against the I can say that against that security candidate, like we can run it against the security tools. By that way itself, we can able to figure out like what are the security loopholes is present in the container image itself. Okay. Now going to the next section, they are read-only, ensuring a consistent and immutable base of our containers itself. So this is most important. They are read-only, and whatever the image, when you build that image itself, it will never ever get changed. Okay, so whatever the image is build it, that is the final image, and you can't change anything inside of. Like if you want to make any changes on the top of it, that new image you have to build it. So that was one of the, I can say, that drawback, but it's also a feasibility. Like there's nothing will be get changed. Like if it's a type of read only, like you can able to view it only, you can't change anything on the top of it. That was also one of the thing. Now talking about the containers, running an instance itself, as we already discussed about it. In case of container, it's a type of instance itself. When we are running the container image, once it's get up and running as an instance, then in that case we call it as a containers. So a container is the actual running instance of a container images. It's like taking the blueprint images and the building a house container based on it. You can create multiple containers from a single image. That's also one of the thing. Like you can run a number of containers from a single image, each acting as an isolated unit. So taking example, if you want to isolate multiple environments, so at the same time you are running the same image, you do not want to get it interact with each another, then in that case you can isolate that by running a single image. You can run different environment which called as the instances. So multiple instances you can run it with the single images itself. Now going further with that, containers share the underlying operating system kernel, making them resource efficient and compared to the virtual machines. So that's also one other thing. So it's sharing that kernel itself, resource efficiency, so it's not consuming a lot of things. Like as per the need itself, is trying to get it optimized as per our need itself. It's not going with that, like when you are running a VM on a system on a 8 GB 16 GB RAM, at the time your system is completely dying. It's not happening in case of Docker. That was a mean. Unlike images, container are writable, allowing you to make changes to the running application state itself. That's also one other thing. Now if I'll talk about the differences, key differences, so state, purpose, creation, sharing, so these are the key differences. So in case of state, image are read-only while container are writable. So container is writable but the image are read-only. Now talking about the purpose, so image serves as a template. It's like a template, so you build it one thing, it's a template, you can utilize it, while containers are running instances. So containers is called it as an instances. When we are running it, it's called it running as an instance itself. Now creation, you can create container from the images. Okay, that's clear about it. Sharing, images are meant to be shared and reused while containers are specific instances. So you can share the images, that's one other thing, but the container, like when we are running instances, it's specific to the instances only. It's nothing like that you can't run it a container somewhere else itself. It's a type of thing, it's specific to the instances. You are running that image and by that way itself you are getting the instance, and that instance we call as a container. By using the container image and the containers, you are achieve what exactly the things you can achieve. So portability is one of the thing we can achieve it. Application run consistently across different environment, isolation, efficiency and scalability. So these are the core 4 things on the basis of the Docker itself, which is feasible instead on the top of it the VMs which you have it used earlier itself. I'm not saying that VMs are not utilized nowadays in industries, it's utilized, but the thing is that most of the places, most of the section itself a Docker is utilized it as per the need itself. Wheresoever there's a feasibility of the Docker, the organization are using the Docker itself. It's more convenient for them. So container technology like Docker has become a popular choice for a developer and an IT professional due to these advantages. It implies software development and the management, making it easier to build, test and run application. So development is not the only thing, testing is also one of the thing, and running the application is one of the thing. So it's bit feasible on a Docker for a developer to run that application, test that application and deploy that also. Now if I talk about the flow of that container itself, so host OS, Docker image, then the Docker runtime and the container. Now talking about the Docker image, container image, so it's application code, dependency, Docker file. This is the file you can able to see that once you get it, clone it or try to get it deployed that, or at the time itself you can able to see this Docker file. Then the base image, whatever the base image of that Docker container itself, and the last one is a layered file system. So that's all about the stuff which I want to get it covered in this video itself. I hope you like this video, and the thing is that I'm just starting with this Docker container security. This is just a theory part itself. In couple of videos you're seeing just a theory part. I'm trying to make a base first. So in the initial phase I'll try to make the base. Once it clear to you, all the concepts clear to you, I'll proceed further with the practical portion for it. But the practical portion I'll just starting from the scratch. It's not nothing like that. I'm just going directly to that advanced stages where I just need to run the commands, showing you the output. No, nothing like that. I'll try my best to make that content appropriately for it. Even I have learned it from the scratch itself. That was the reason I'm trying to make it in the appropriate way, so that you can able to understand the Docker security also appropriately. Okay, so thank you so much once again. Take care, bye bye, and please like this video. If you like this video, please subscribe my channel also. Thank you so much, and once again, bye bye.